Hi, fifth graders. It's Mrs. Lemoyne again, and today we're going to be doing Unit 7, Lesson 13 Perimeter and Area of Rectangles. All right, let's see what our goal is today for today's lesson. We're going to explore perimeter and area of rectangles on the coordinate grid. Here's our warm up. What is the area of one window? Record an estimate that's too low, about right, and too high. Excuse me. So when I look at these, I have no measurements. So how in the world am I going to estimate what the area of a window is? But I do notice that on these windows, I have some people. Looks like they're glass cleaners. They're cleaning the windows, right? So I can maybe use the size of that human right here. I'm going to look at this human and this human, okay? To see if I can figure out what the length and the width would be of one window. Well, I know that the average human is about 5.5 to 6 feet tall, right? 5.5 to 6 feet tall. And so this human looks like he goes up that much. So how many more feet do you think I should add if let's say he is 5.5 feet tall? 5.5. So it looks like I could put another maybe half of a human on top of that. So half of 5.5 would be what, 2 and something. So let's say I'm estimating, so I get to estimate. I'm going to say that the height of this window is about 7, maybe 7.5. And then the width of the window, it looks like I could probably fit maybe 2 humans across, maybe 3. So how wide do you think the average human is? How wide? Would they be 2 feet, 3 feet across? So if they're 2 feet across, then that would make this about 4. I'm going to go ahead and estimate 5 just because, right? Just because. So about right would be 7.5 times 5. So let's see what that is. 7.5 times 5. We're multiplying decimals, so I know that I'm going to move that decimal when I am done multiplying. 5 times 5 is 25. And 5 times 7 is 35 plus 2 is 37. And then I have 1 decimal point, so I'm going to move it about there. So for me, I think that the area of one window might be about 37 to 40 feet, because remember, I'm estimating square feet, feet squared or square feet. So too high would be maybe 100 square feet. And too low, of course, might be something about 10 or 20 square feet. Square, Miss Lemoyne, feet. All right. So I had to use the size of these humans to help me estimate the length and the width. And I'm remembering that length times width, or height, the height of the window, how tall it is going to give me a good area. So this would be feet squared or square feet. All right, let's see if they ask us any questions about that. Oops, let's erase some of this. How could you use the image to help you estimate the area? And you saw how I did that. I estimated the size of a human and the width of a human. And that's what helped me to figure that out. Okay, Jada drew a rectangle with a perimeter of 12 centimeters. I remember that perimeter has that word rim on it, so that means that I'm taking the outside and adding up all the sides to find the perimeter of my rectangle. So we know that when Jada adds up the length and the width and the length and the width, she gets 12 centimeters. So what could the lengths and the widths be? Well, I know that this length and width has to be the same as this length and width because it's a rectangle, right? So it has to have equal opposite sides. So if I add up half of the perimeter, it will give me half of 12, right? Half of 12. And what is half of 12? 6. So the length plus the width of this side has to equal 6. It has to. because the length and the width of this side has to equal 6, and these two things are the same, and these two things are the same. So what numbers could the length and the width be to add up to 6? So what could I use? I could use 1 and 5. Could I use 2 and something? Yeah, 2 and 4, right? So if I did that, here's another rectangle so I can start it, right? If the width was 1 and this was 5, that would make these 5. Oops, that's a 1, right? So I would have 5 plus 1 is 6, plus 1 is 7, plus 5 is 12. Or I could say 5 and 5 is 10, and plus 2, 1 and 1. I could do the same thing with a rectangle and say 2 and 4, couldn't I? So if this was 2 and 2 and this was 4 and 4, when I add up all those sides, I'm going to get 12, which is what I want. What else could I get 12? Could I do a side that is 3? So if that means one side is 3, that means this side is 3, and this side is 3, and this side is 3. When I add up all those 3's, do I get 12? Yeah, remember I have to get 2 of the sides together, has to get 6. So that works. All right. And then I could do the opposites, couldn't I? I could have a side that's 4, that would make this side 2, and I could have a side that's 5, and that would make this side 1. Okay, I hope that you understood all of that I just said. Drawing pictures really helps me to clarify my thinking, so that was very helpful. Okay, so remember, we were talking about perimeter, weren't we? And we decided that half of the rectangle had to equal this side plus this side had to equal 6 in order for the entire perimeter to be 12. All right, now it says, so I figured that out. Now it says plot the length and width of each rectangle on the coordinate grid. So here's the length and here's the width. So if the length is 1, the width has to be 5. So I'm going to put a dot there. If the length is 2, the width has to be 4. If the length is 3, the width has to be 3. If the length is 4, it's 2. And if it's 5, it's 1. All right, that makes sort of a straight line, doesn't it? It's nice and symmetrical. I love that. If Jada drew a square, how long and how wide was it? Well, I remember from the last unit, or for the beginning of this unit, a square has to have all equal sides, doesn't it? So which one has the same length and the same width? 3 and 3. So 3 and 3 for that one. Okay, so I'm going to erase some of these things because I think I need this chart on the next problem. You can just refer to the one in your workbook. Here's 4. If Jada's rectangle was 2 and 5/10 centimeters long, how wide was it? Plot this point on the coordinate grid. So let me draw again to help me figure that out. So long would be 2 and 5/10 centimeters, and we need to know the width. So I know that this is 2 and 5/10 centimeters. So remember, if I have the perimeter, this half, this plus whatever this is, has to equal what? It has to equal 6. So if I have 2 and 5/10 centimeters plus something has to give me 6 in order to have a perimeter of 12. So how am I going to find out what this is? So 2.5 plus 6 equals, no, sorry, plus what? Plus what equals 6? Remember, we want to get half of that perimeter to be able to find what this is. So to do that, I'm going to do the opposite of adding. I'm going to subtract. Now remember from my decimal unit that I'm going to have to line up those decimals. And for the 6, I'm going to have to add a decimal, aren't I? So that I can line them up. And I'm going to have to subtract. So I'm not going to worry about that decimal, and I'll put it down here and just subtract. So I can't take 5 from nothing. So I'm going to have to borrow 1 from the 6 and make that a 5. Now I take that 5 and this becomes a 10. 10 minus 5 is 5. 5 minus 2 is 3. Now, a good rule of thumb to help me know that this is correct is I'm going to go ahead and add back the 2.5. And what should I get as an answer. I should get 6 so that I know that 3.5 or 3.5 is the width. Okay. Now I'm supposed to plot this point on the coordinate grid. So I have to go over, let's see, what color do I have right now? I'm going to stay in pink because I want it to be a different color than these dots. So I have to go over 2.5. So here's 2. I'm going to go about halfway there. And then I'm going to go up to 3.5. What happened? That dot landed in the same line as the other dots. That's interesting. All right, now that's number 4. Number 5, if Jada's rectangle was 3 and 25 centimeters long, well, I'm going to do the same thing, right? Except now this is 3 and 25 hundredths, and this is 3 and 25 hundredths. So what is this? So this plus this is going to give me that 6. So 3 and 25 hundredths plus what gives me 6? Because I have to have 6 to get half of that perimeter. So now I'm going to have to subtract just like I did with the 2.5. So I'm going to go over here and do 6, and I have to add a 0, minus, I'm going to have to add 2 zeros, aren't I? 3 and 25 hundredths. Now I can't take nothing away from 0, or I can't take 5 away from 0, so I'm going to have to borrow. So I'm thinking of this as a 60. I'm going to go ahead and make it a 59. So there I have borrowed from the 2 over here. 10 minus 5 is 5. 9 minus 2 is 7. I'm going to keep my my decimal point, not my denominator, my decimal point. And 5 minus 3 is 2. So just like I did with the other one, I'm going to check my work. I'm going to say 2 and 75 hundredths plus 3 and 25 hundredths, and that should equal 6, right? 7, 8, 9, 10, decimal point, carry the 1. 2 plus 1 plus 3 is 6. Okay, so if my rectangle is 3 and 25 hundredths long, it is going to be 2 and 75 hundredths wide. So now I'm going to go all the way over to 3, nope, closer to 3. 3 and 25 hundredths is closer to 3 than to 4. And then I'm going to go up to almost 3 for 2 and 75 hundredths. 2, between 2 and 3, and closer to 3 than 2. Look how it made a nice, neat line. I love that. I love that. All right, let's see what questions they ask me about this problem. So I'm going to go ahead and erase. Let's see. They asked me something else. Nope. Go ahead and erase all that work. You have it in your notebooks, hopefully. How did you find the widths of Jada's rectangle if it was 3 and 25 hundredths centimeters long? Well, I knew that the length and the width together are half of the perimeter, and it had to equal 6. So I subtracted 6, or 3 and 25 hundredths from 6, and that was 2 and 75 hundredths. What happens to the width when the length decreases by 1? It's a good question. The width decreased by 1, didn't it? This makes sense because the sum has always got to be 6, right? It has to stay the same. How does the graph show this? Well, when I plot it, for each point that I plotted, I can go right 1 and down 1 and find another possible length and width. Or I could go up 1 and over 1, right? Over 1 and up 1, I should say. And I would always find something in that line. Remember the line that it made? So every point on that line is something that would make a perimeter of 12. All right, here we have a new problem. This time we're going to talk about area. Jada drew a rectangle with an area, so here's my rectangle, of 16 square centimeters. So now I know that it's going to be length times width. So I'm going to do length times width to find the area. What could the length and the width of Jada's rectangle be? So if I had a length of 1, then the width would be 16. So all of these have to equal 16, and I'm multiplying this time, right? So what else? Could I do 2 times something? 2 times 8 is 16. Could I do 3 times something? I don't think 3 times anything, because 3 times 5 is 15 and 3 times 6 is 18. So 3 won't work. What about 4? Well, I know 4 times 4 is 16. What about 5? Nope. 5 times 4 is 20. 5 times 3 is 15. So I'm going to go back and I'm going to use 8, because I know 6 and 7 don't make a 15. They don't go into 16. So 8 times 2 is 16, and 16 times 1 is 16. All right. What could the length and width of Jada's rectangle be? Use the table. We did that. Now we're going to plot the length and the width for each rectangle on the coordinate grid. So my lengths will be here and my widths here. Let's start with this one. 1 and 16. Unfortunately, I think the one in your book does go up to 16. This one doesn't. So I'm going to have to estimate, right? So I think estimating 1 and go up to 16, I'm going to put my dot way up here. 2 and 8, that fits on this graph. So if that happens, boys and girls, if it's off the graph, you just kind of estimate, okay? 4 and 4, 4 height, 4 width, 4 length and 4 width. 8 length and 2 width. And then here I have to do it again. I'm going to have to extend this line, and I'm going to estimate that this is 16, and I'm going to have to go up 1, aren't I? So this one, let's do it like that so I don't confuse you. So I'm going to estimate that this is about 16, because it's 16 and 1, right? This one didn't make a straight line, did it? Kind of made a curved line like that. So why does this one make a curved line and the other one make a straight line? That's a good question. So let's continue. I'm going to get rid of all this extra stuff, because I think I need this information for the next problem. Let's see. Yes. If Jada's rectangle was 5 centimeters long, how wide was it? Ooh, okay. So again, here's my rectangle. I need 5 times something to get 16. So that's not going to be a whole number, because there's nothing times 5 that will get me to 16. I just told you guys 5 times 3 is 15 and 5 times 4 is 20. So I'm going to have to do what? 5 times what equals 16? Well, that's a division problem, isn't it? 16 divided by 5 equals what? I could write it as 16 fifths, but I'm still going to have to go over here and do this. How many times will 5 go into 16? Well, it will go 3 times, with how many left over? 1. We could add a decimal, right? 5 goes into 10. I have to put it up here too, right? 2 times, with nothing left over. So if the length was 5, then the width would be 3 and 2/10, or we could say 3 and 1/5. 3 and 1/5, if I wanted to use a fraction, because this was what was left over, right? All right, so for this one, we answered it up here, 3 and 2/10 centimeters, or 3 and 1/5. If Jada's rectangle was 3 centimeters long, so now my rectangle is 3 centimeters, how wide was it? So 3 times what will give me 16. Again, I don't know what that is, so I'm going to have to divide it out. So I'm going to do that one over here. So remember, I can write 16 divided by 3, or 16 thirds. So over here, I'm going to work it out. 3 goes into 16 5 times, with 1 left over. And this time I am going to keep it a fraction, because I know that if I added a 0 and brought it down, I get 10, right? And that's not going to ever go in evenly. So I'm going to say that it would be 5 and 1/3 centimeter long. And now, so I'll write it down here. 5 and 1/3 centimeters wide, I should say. Wide. And this was centimeters wide. Okay. If Jada drew a square, how long and wide was it? Okay, so a square means that this side has to equal this side. And in my chart, the only one that does that would be 4 and 4. So 4 centimeters long and 4 centimeters wide. Okay, let's see what else they ask us to do. Oh, I forgot this point. I have to plot these on the coordinate grid. Okay, so for 5, I'm going to go over 5 and I'm going to go up to 3 1/5 or 3.2. So not very high, right? So I'm going to go over 5 and up a little above 3. Okay, so there's that first one. And then I have to plot this one, 3 times 5 1/3. So I'm going to go over 3 and up to 5 and a little bit above that. Okay, so you can see it does kind of fall into this curve, but it's not a straight line, is it? It's not. Okay, so did I do everything it asked me to do? I found out how wide it was, I plotted it. I found out how wide it was, I plotted it, and then I figured out that it would be 4 and 4. Okay, so let's move on. I'm not sure if I need to keep all this stuff on here. No, so I'm going to delete that. If Jada's rectangle was 5 centimeters long, how wide was it? Well, we figured that out, right? It was 16 over 5. And then we had to divide that, and it became 3 and, what was it, 3 1/3? How did you calculate the value? Well, we did division, didn't we? Right? We did division. So it would be 16 over 5, which would be 3 1/5, or 3.2. That's what it was. Yeah. Did you know where to plot the length in the pair? It was a little bit harder because this is a fraction or a decimal, but yes, we could plot it. How did you determine the possible lengths and widths for a given area? The same as determining the possible lengths and the widths for a given perimeter. Well, it kind of was, right? I knew that perimeter, I was adding up all the sides, so I used addition instead of multiplication. But when I'm used for perimeter, right? For area, I'd use multiplication and division to find out what the possible lengths could be. How are the length and width pairs? How are the length and width pairs for the rectangles with an area of 16 different from the length and the width pairs for the rectangles with a perimeter of 12? Well, first of all, I could determine with the perimeter, I could determine where it was going to fall because it made a straight line, didn't it? I knew that every time I looked at it, I could find it on that straight line. It was a little bit harder. When the length increases, the width decreases. When the width decreases, the length increases. And I can flip the order of the length and the width. Remember doing that? Yeah. Okay. The difference is, let's see. When I was looking for 16, I was looking for things that multiplied to get 16. When I was looking for 12, I was looking for adding up all the sides with a total of 12, or I was looking for a total of 6, right? So that was a little bit hard. Okay, so today we plotted lengths and widths of rectangles. Here we are on the coordinate grid. How are the graphs the same? Well, they both show lengths and widths of rectangles. When the length increases, the width decreases. So we all have a line or a curve going this way. When the length increases, when it gets bigger, right? So here we have a 5, which is a bigger length. The width gets smaller. It goes down to 1. When the length is at 3, the width is at 3, so that's the same. But when the length is small like 2, the width is bigger at 5. So same thing over here, right? The bigger the length, the smaller the width. Okay. So the smaller the width, I guess I should say point right there, not up here. And the bigger the width, the smaller the length. Let's see what else they ask us. How are they the same? Let's think about that. Or different. We just talked about how they're different. Same. The length and width pairs with the perimeter of 12 are nicely organized in this nice line, right? When the length increases by 1, it decreases the width by 1. So if I have 2 going to 3, I increase to 3. The width goes down to 1 from 4 to 3. But with the 16, with this graph over here, the length and the width pairs with area of 16 don't follow a clear pattern. I wouldn't be able to guess any other values. Over here, I could guess this one, all in this line, right? But here, it's not a straight line, so it'd be very difficult to guess any other values. All right, let's see if we can do that cool down. Okay, the point represents the length and the width of a rectangle. What are the area and perimeter of this rectangle? So the first thing I'm going to do is draw a rectangle and draw a rectangle. This one's going to be perimeter. Oops. There we go. Perimeter. And this one's going to be area. Two different things we have to do, right? So I see that the length for perimeter is 4 and the width is 5. So that means this is going to be 4 and this is going to be 5. So I know that the perimeter equals what? 18. I did 5 plus 5 is 10 and 4 plus 4 is 8. And I did 10 plus 8 is 15. And that means it's going to be 15 centimeters long, not squared. Now I'm going to do the area. I already labeled it. I know that the length is 4 and the width is 5. So remember, I'm going to multiply those two together and I'm going to get an area of 20. And I have to write centimeters squared for that one, or square centimeters, because I'm talking about area. Here we're talking about the length around it. Okay, what is a point that represents a different rectangle with the same area? So we have right now, we have length and width of 4 and 5. So what would, and remember when we multiply those, we're getting area, we get 20. So what would be another set of numbers that I could use to get 20? Well, I could use 5 and 4, couldn't I? That would be easy. What else would give me 20? Could I do 1 and 20? Yes, that's a rectangle, isn't it? 1 and 20. Could I do, what else equals 20? What about 2 and 10? That equals 20. And that means I could do 20 and 1 and 10 and 2. All of those would be different rectangles, right? 10 and 2, or 2 and 10. 2 and 10 would be a really tall, skinny one. 10 and 2 would be 10 and 2 would be a long one like that. All right. So these are all the ones that are, well, these are the same, but these are all the ones that could be different. So I could say, let's just pick one, 2 centimeters wide and 10 centimeters long length. All right, boys and girls, that is it for Unit 7. And it's it for all of the units for 5th grade math. Thank you for joining me. And again, like and subscribe if you like these videos and if they helped you with your math this year. Thanks again, boys and girls.